So let's go ahead and do an exercise now that involves these formulas from step 2 of our development of trig functions. The exercise is find the values of the 6 trig functions of theta, where theta is as pictured. So not only are we going to find sine, cosine, tangent, we'll also find secant, cosecant, and cotangent. And I did make a yellow card with crucial information from the last video on it. And really it's what's in the box that we got to use from now on. And it grew out of SOHCAHTOA, but we've really moved beyond SOHCAHTOA because we're going to be able to use these formulas even when the terminal side is outside of the first quadrant. So let's go ahead and start doing this problem. Now, where's the circle is the question I would have first of all. Like to apply those formulas we need an R, and so I'm going to draw a separate picture here so I don't write on the original picture. I'm just going to recopy this terminal side with the point -3, 1. And what you got to do here in order to apply these new formulas is we need a circle center at the origin. We want -3, 1. We want it to be that point xy, right? We want it to be the point where a circle touches the terminal side. So we actually got to imagine the circle centered at the origin. That passes through that point. We're picking one very particular circle that I drew a little sloppily. And we need R for this circle. Now its equation would be x squared plus y squared equals r squared. That's the form the equation takes for any circle centered at the origin. And we know -3, 1 has to satisfy that equation. So what we can do is we can just plug in -3 squared plus 1 squared equals r squared to come up with a value for r. 9 plus 1 is r squared. 10 is r squared. Now we got to take square roots. There are 2, but again here r is a length, just like we saw earlier in the course, so we just need the positive square root here, square root of 10. Some people like to use the distance formula here too. You could have done it that way because the center of the circle is 0, 0, and the radius of this circle is the same as the distance from -3, 1 to 0, 0. So you could compute that distance and you should get the same thing. So here's our r equals square root of 10 on that circle. And now I'm basically just going to plug into the formulas that we have, okay? So sine of this angle, sine of theta, is equal to y over r. The y coordinate is 1. The r value is square root of 10. Here's the sine of that angle. Cosine of theta is x over r. The x coordinate is -3. The radius is square root of 10. So -3 over square root of 10 is the cosine. And you can rationalize those if you want. I'm not going to do that right here. But just notice the cosine's coming out to be negative. Tangent of theta is y over x. That's going to be 1 over -3, or negative a third, that's also a negative value. So we got sine, cosine, a tangent. We actually wanted to find all 6 trig function values, right? So slide this up again. So let's go through the 3 remaining. Secant theta. Now what you got to remember is secant is 1 over cosine theta. So it's 1 over negative 3 over square root of 10. So it's the reciprocal of that fraction, or just you can write negative square root of 10 over 3. So if the cosine is negative, the secant is also negative. The cosecant of theta is 1 over the sine of theta. So that's 1 over the square root of 10, which is square root of 10 over 1, or square root of 10, cosecant theta. And the cotangent theta is 1 over the tangent of theta. So that's 1 over negative a third, or negative 3 over 1, or negative 3. Okay, so that's it. These formulas in the box are crucial, really important now. And the big surprise here is that we're sometimes getting negative values for the trig functions.